Hello everyone, welcome to this session. We are going to talk about water treatment in parts. We are going to talk about each process involved in this wastewater treatment. You can see here an aerial picture from a wastewater treatment plant, and you can see there are many modules. So the disposals of wastewater it could be from a plant industry. It's a difficult and costly problem. You could see here a chart that it has stages of wastewater treatment. We have it here: pre-treatment, primary, secondary, and tertiary treatment. You have the entry in here. It could be a public channel network, and then is pumped in here through a bar screen, and then to the grease and grit removal. There are many types of grit. These systems are using gravitational force to remove these little points. It are representing the fat, and the grit is removed these materials by the using gravitational force that is going down the fat, and we can remove the not water soluble contaminants, because in general they float in the surface, but we can also addition some chemicals, and then we have our grace balls form, and those particles are removed. Then we are going to talk about the next stages, but in here in the pre-treatment, the objective is to contain what might damage the treatment equipment. So we have the general spillway, trash racks, some screens for those solids that are very large, that they are called coarse solids, and then for the fines. And as we said, to avoid damage in the equipment, we have to sand it in the grease by a grit. In here we also take advantage of this stage to measure the flow of the current that is entering to the wastewater treatment drain. That's for the pre-treatment, and then we have this stage that is a primary treatment. Is in general called a primary clarifier, this equipment, and in here you have the primary sludge that is passing to the sludge treatment. So in this primary clarifier, you just separate the solids mechanically, because we have a solid and liquid part. Then you separate the solids, and then you obtain the primary sludge, and then the liquid is going to the next step. For the primary treatment, time between 4 and 24 hours, and we could have some stabilization points in here. Not really in all times we have this, but sometimes we have to put an stabilization point, and we have to consider for the design that segregation of residual lines of higher organic content can result in substantial decrease of in the flow. So we have to reduce the volume of the retention tank. If you could see the chart in here, there's simply is a tank, and you are separating the two phases. So it could be very simple, but this is the pre-treatment. You have in here a picture about it. This is the tank, and you have these parts where you obtain the sludge in the bottom of the tank, and we have in here all the parts you could use gas vent, and the liquid is going from here. This primary treatment includes chemical treatment, anaerobic pump. You remember anaerobic is without oxygen, and as I'm saying, this tank is a primary decanter. Are separated two phases, liquid and solid, and you could have dissolved air flotation that is entering here the gas, and it's called generally as IMHOP tank. You can see that primary treatment is consists in a large container and the small particle sediment in the bottom of the container. So you have in here the equation to obtain the channel width. This is the collector from wastewater, and then enters to the container, and then is filtered by this mesh, and then you have in here the decantation exit, and then you are eliminated all those solids that are floating in here. If you remember the pre-treatment, we also said that we are screening the large solids, and some plants use primary and pre-treatment as one the same operation. So in here you eliminate the solids and you obtain in here, and then you have the sludge down here and to the sedimentation tank and the sludge treatment. As you can see the formula, you have a constant value, then the flow rate, the velocity through the shear bars, that is these ones, and well, this constant is an empirical factor. You could also have this primary treatment as primary sedimentation. You are obtaining here the wastewater filter, and then you have a second tank of sedimentation, the sludge, and then the treatment for the sludge, and in here the liquid part is obtained as the effluent water, and in the sludge treatment you obtain also some gases that could be used in other parts of the plant. So in here we have also an equation to obtain the sedimentation velocity. You can design the tank using this equation. So we have we need the particle radio that you can obtain as for the empirical factors, and the viscosity of the fluid, the density of both solid and fluid, and the superficial area. So in here we have, as you can see, we are using G, that is gravity acceleration, because this is the theoretical part that we are using to design this treatment. So what are the types of design for these sedimentation tanks? We could have a horizontal flow or a circular or a vertical sedimentation. If you can see, the designs are determined by the flow of the sedimentation tank. So there's these three types: horizontal, circular, and vertical. Circular sedimentation tank is very common. So that's the three types of the design. We have in here a chart for the clarifier. And you have in here the clarifier effluent, and then the screening bar. You remove the solids, and then here is the feed, and it's the sludge out, and then the sludge also has to be screened by this bar to give that to the sludge treatment. So this is another photo of the wastewater treatment plant. If you can see, you have to consider in the design all the appliances to the engineers could be walking down the plant and seeing the monitors for the equipment. That's the two first steps for this wastewater treatment plant. Goodbye.